Hey there. So we're talking about the parallel-axis theorem. This is going to show up only once or twice in this chapter, but I want you to be aware of it just in case you need to use it later on in your studies or to tackle a harder problem. It's called the parallel-axis theorem because we are looking at rotation around a parallel axis to the axis through the center of mass. And generally speaking, we're going to give you a list of moments of inertia, and that list is actually generally through the center of masses of objects. Sometimes it's not. Sometimes it's around the edge of an object. Sometimes it's through an off-axis point. But the parallel-axis theorem allows us to take those known and easy to calculate moments of inertia and actually translate them to other places. So the idea here is that I can have any shape that I want, any shape of object, and let's say I know the center of mass, and let's say I know the moment of inertia through the center of mass. Now, I'm not going to pivot around the center of mass. No, I'm going to pivot around this point. Where is that point? Well, it's some distance d away from that center of mass. I'm going to pivot around there. So to find the moment of inertia around that pivot point, I'm going to say it's equal to the moment of inertia around the center of mass plus the total mass of the object plus the total mass of the object times d squared. That's it. So you can literally find the moment of inertia about any point on this object if you know the moment of inertia through its center of mass. And again, just to illustrate kind of why we're calling this the parallel axis theorem, if we think about rotating it around this axis, through the center of mass, the axis around our pivot point now is parallel to that around to the axis through the center of mass. So parallel axis, right? And it's pretty much that simple. If I know ICM, and I know the total mass, and I know the distance between the center of mass and that point, I can find the moment of inertia through that other pivot point, which is powerful. That's actually really, really powerful. So I mentioned that a lot of times we'll just give you a table of moments of inertia. I'm going to put that in this video. If I haven't already put it in the other video, I'm definitely going to put it in this video. You can find that in your book. You can find it in the chapter. You can also find it online. Wikipedia actually has a really good list of moments of inertia. So I'm going to put that in. Next time we're going to talk. We're going to start talking about how to use moments of inertia, right? Just like we used mass and acceleration to start talking about rotational force, right? Which we're going to call torque. So that's next time. I'll see you around. Have a good one.